Hey class, Mr. Mujin here with another video on triangle congruence proofs, once again using the idea of cpctc. One way you can tell that that's going to appear in this problem is our proof statement is not a triangle, but rather part of a triangle, BT and FR, or parts of triangle I should say. So I've started the proof a little bit just to save a little bit of time. The given information is always the first thing, so I went ahead and put it there. Now one thing I want to make sure you notice is that we're given this information as being true, but notice that our picture has no markings. And sometimes geometry problems are like that, where you know something is true, but the visual isn't quite representative. So always double check that what you're actually given is marked in your picture. So TF being the same as RB means that these two are the same length, and it's going to be useful for us. And TF being parallel to RB, well, that means that these are also the same direction, so they're parallel. So that was not actually marked in the picture, so I want to make sure that it becomes marked. And I encourage you to double check, and also as you make statements, make sure that that is visually represented as well. So one thing to notice is that we have parallel lines, so hopefully by now you know that alternate interior angles are probably going to appear at some point in this problem. What you also notice, hopefully, is that you have a shared side here that belongs to both shapes. It belongs to the top shape, and it belongs to the bottom shape. So the reflexive property will also be involved. So let's dive right in. The parallel lines is a good observation to begin with, although really the order of these next two steps is sort of up to you. So I'm going to say that this angle right here looks like it's the same as this angle right there. And you know, they might appear to be the same, but I know that they are based on these fact that these are parallel. So I know that those two lines are parallel, so those two green angles are therefore the same. So based on the fact that they're alternate interior angles, now well, I gotta be careful with their naming here. So the vertex of the top one is F, so I know it's gonna be angle something F something. So it looks like it's TFB would be one way of naming it. T to F to B is the same as, well, the vertex of the other angle is B, so B is going to be in the middle there, and it looks like T to F to B would be the equivalent to R to B to F. R, B, F. And the way I know that is T matches with R, F with B, and B with F, because that's where these angles are alternate. So those angles are the same by alternate interior angles. We said earlier that they share a side, and that's a pretty dead giveaway that the reflexive property of them being the same as themselves is going to appear. So we know that in one scenario we have BF, and in the other scenario we have FB in the mirror, or the reflexive reflection, same basic root. So BF is the same as FB because of the reflexive property. It's the same side, literally, in both shapes. They're overlapping. And the way we indicate that is just to say that, well, that side is knowable, it's marked. So if you look carefully here, maybe it'll help to draw two separate triangles off on the side here. We have one triangle, if I were to split these apart, we have one triangle like this, and another triangle like this, sort of like two parts of a sandwich perhaps. And we're marked with these as the original givens, these two as the reflexive sides that are the same in both shapes because they overlap, and we identified these angles as being the same because of alternate interior. Well, this appears to be a textbook case of side angle side, right? Because you got two sides and an angle in between, and here you got two sides and an angle in between. So even though I don't have full information, notice that the other marks in the triangles are not known. I know that by side angle side these two shapes must be the same. So once again, be careful with the naming. TFB, the first shape. If I call that one TFB, then the other shape must be called TFB. That should be RBF. And how do I know they're identical? Because of side angle side. That's enough information that it always makes the same shape as we saw on the computers several weeks ago. So we're not done. In the past we'd have been done because we've shown shapes are the same. We now have to say whether or not the parts are the same. So notice BT, that's the third position, use a different color here, the third position, and the first, and FR, looking back at the proof statement, so FR, well, what do you know, they're in corresponding spots. So we can say that BT is the same as FR because corresponding parts, they're in matching positions over here, of congruent triangles. We just proved in step 4 that they are congruent. Well, those parts themselves are congruent. Q, E, D. See you later.